people first hear about Kafka, a common reaction is to wonder why we need it at all. After all, aren't there already plenty of message queues out there, or even the classic old-school queues? It's a fair question, and the answer lies in understanding what problems each tool is designed to solve. In this video, we'll break down the differences between traditional message queues and Kafka, so you can see why Kafka isn't just another queue, but something fundamentally different. Let's start with the basics, traditional message queues. Imagine a message queue as a simple task list. A producer sends a message into the queue, and a consumer picks it up. Once the consumer processes the message, it's removed from the queue and is gone for good. This model is straightforward and works well for many use cases, especially when you need to handle background jobs, send emails, process images, or manage other simple synchronous tasks. But as we'll see, this simplicity comes with some important limitations. Traditional message queues shine in scenarios where you need to get work done in the background. For example, if you're sending emails, processing images, or running simple asynchronous jobs, queues are a perfect fit. They help decouple producers and consumers, making your system more resilient and scalable. However, this model assumes that once a message is processed, it's no longer needed. That's great for simple workflows, but what happens when things get more complex? Despite their usefulness, traditional queues have some notable limitations. If a consumer is slow, messages can pile up, leading to delays. If multiple systems need access to the same data, things get tricky. Queues aren't designed for sharing messages with many consumers. And perhaps most importantly, once a message is consumed, it's gone forever. There's no way to replay or reprocess it if something goes wrong. Queues are about doing work, not about keeping a history of what happened. RabbitMQ is a popular message broker that builds on the traditional queue model, adding more flexibility and features. It supports advanced routing, fan-out messaging, acknowledgements, and retry mechanisms. This makes RabbitMQ a great choice when you need guaranteed delivery, complex routing rules, or want to ensure that messages are processed exactly once. But even with these enhancements, RabbitMQ still treats messages as temporary. They're gone once consumed and acknowledged. Let's look at a typical RabbitMQ scenario. Imagine an order service sends a message to RabbitMQ. The broker decides who should receive it and how, based on your routing rules. This is powerful for building event-driven systems where you need control over message flow. However, RabbitMQ still operates on the principle that messages are processed and then disappear. It's great for event-driven workflows, but not for storing or replaying events. A key point to remember is that both traditional queues and treat messages as temporary. Once a message is consumed and acknowledged, it's removed from the system. This means you can't go back and reread or replay messages. If you need to keep a history of events or allow multiple consumers to read the same message, this model falls short. That's where Kafka comes in, offering a fundamentally different approach. Kafka doesn't follow the traditional send and forget model. Instead, Kafka thinks in terms of streams of events. When a message is sent to Kafka, it's written to disk and stays there for a configurable amount of time. This means multiple consumers can read the same message, and each consumer controls its own position in the stream. Nothing disappears just because one service has read it. This is a massive shift from the queue mindset. With Kafka, the focus shifts from doing tasks to recording what happened. Kafka is more like a commit log than a queue. When an event occurs, it's written once and can be read by many consumers, each at their own pace. This enables powerful patterns like event sourcing, analytics, and real-time monitoring. Instead of just getting work done, Kafka lets you keep a history of everything that happened, making it easy to replay or audit events later. One of Kafka's biggest strengths is that multiple consumers can read the same event independently. For example, when an order-placed event is written to Kafka, the billing system, notification service, and analytics platform can all read that event, each at their own pace. This enables powerful integrations and decouples your systems, making it easier to scale and evolve your architecture over time. In Kafka, each consumer keeps track of its own position in the event stream. This means consumers can pause, rewind, or skip ahead as needed. If a consumer fails or needs to reprocess data, it can simply start reading from an earlier point in the stream. This level of control is impossible with traditional queues, where messages are lost once consumed. Kafka's approach gives you flexibility and reliability. Here's the simplest way to remember the difference. Queues are about doing this job, while Kafka is about recording events. This happened. Kafka acts more like a commit log, keeping a durable record of every event. This distinction is fundamental and shapes how you design your systems. If you need to keep a history, enable analytics, or support multiple consumers, Kafka is the tool for the job. Sum up, while traditional message queues are great for getting work done in the background, they're not designed for keeping a history or supporting multiple independent consumers. Kafka, on the other hand, is built for event streams, persistent storage, and flexible consumption. It's a different mindset, one that's perfect for modern, data-driven architectures. Understanding this difference helps you choose the right tool for your needs.